The first orbit consists of two electrons. You can see there are two electrons. Then there are second orbit, there are 8 electrons. You can see there are 8 electrons in the second orbit. In the third orbit, there are 18 electrons. And in the fourth orbit, that is the last orbit of the copper atom, there is only one electron revolving round the nucleus. This is the nucleus where the protons and the neutrons are situated, and the electrons revolve round the nucleus. So the fourth orbit, where there is only one electron, that electron is loosely bounded, and when there is an external energy or a heat given to the electron at room temperature, it freely moves around the copper wire. So this is a copper atom and this is a copper wire. You can see the electrons freely randomly moving in all particular directions in all particular velocity. This is the view of the electron microscope. If you zoom into a copper wire that is the thickness of a human hair, you will see cations and the electrons. You can see small dots, that is the free electrons roaming randomly here and there, and the positive charge you see over here is the charge of the atom. When the electron over here leaves the outermost orbit, the copper atom gets a positive charge. So all these positive charges over here, the cations, are the copper atoms where the electron has uh, been removed from the outermost orbit, and it is freely roaming here and there at room temperature within the conductor itself, within the metal here is considered as a copper wire. So suddenly uh, when there is a voltage source or a battery connected across the copper wire, you can see what is happening is that since electrons are electronegative, it tends to move from towards the positive terminal. So you can see they are moving in a particular direction. So this is called the electromotive force. What happens is that electrons is pushed to the positive end of the cell or the battery. So this is the concept behind the electromotive force of the cell. Good day students, this is Renny and we will be talking about the voltage difference, and today we will be speaking about what is capital V. It is called voltage difference. So before going into the details of the same, I will try to explain through an illustration. Over here there are two breakers. You can see one is in high altitude, and the second beaker B, it is in lower altitude. So you are already aware, once the water is filled in beaker A, the water flows from the beaker A to beaker B, right? It flows from beaker A, and the level of water, you can see it is slowly coming down, and the water flows from higher potential to a lower potential. So this is the concept behind what is potential difference. The concept here remains the same. Here the water flows from high potential to the low potential. You already seen that. So what is happening is that we are talking about voltage. So voltage comes as far as current is concerned in an electrical circuit. So what is a V, capital V voltage? It is the potential difference. The potential difference is high potential and the low potential. High potential we abbreviate as a positive, and the low potential as a negative. So here there is a potential difference created across, which brings the current I. You can see over here the current I is abbreviated over here. So what brings the potential difference is that once the potential difference is created, once there is a positive high potential and a low potential, accordingly the potential difference gets created. It brings a current in the sense there are charges flowing inside the metal wire or the metal conductor. So the potential difference brings the current, okay. And the battery, here the battery is um, more than a cell. Cell has 1.5 volts and battery should be more than 3 or 3 volts. If it is 3 volts, again it is called a battery, and if it is more than 3 volts, it is called a battery. So the battery possesses potential difference V. Okay, so battery is the main source of potential difference, that you need to remember. Battery also displaces the electron in one particular direction. We will be giving that with example over here. So how it moves the electrons in a particular direction. So we have seen in the video wherein we have taken an example of a copper wire, and we have seen the freely moving electrons moving to a particular direction over here. So this same direction the battery is displacing the electrons, whichever the electrons are passing. The electrons are charge carriers, you remember, right? Electrons are charge carriers, it moves in a particular direction. So this direction of displacement is primarily due to the battery, and battery has potential difference, and it creates the potential difference. Once it creates the potential difference, accordingly I is generated, current I is generated. So this is the copper wire where freely moving electrons are there, and you have seen there are cations and there are electrons freely moving randomly at different velocities. So once a battery source is connected, it moves only in one particular direction. That is what it is written over here, only in one particular direction, and this is called EMF of the battery, EMF of the cell, electromotive force of the cell.